Hello, it's Chad Keel from NatureReconnectionClass.com and Learning Geology on Facebook. And today I'm here with one of the most ubiquitous, plentiful, and durable minerals on planet Earth, and that's quartz. Stick around, let's go check it out. Quartz is a chemical compound consisting of 1 part silicon and 2 parts oxygen. That's why it's referred to as silicon dioxide. Quartz is one of the most abundant minerals found on the Earth's surface. It forms at all temperatures and is abundant in igneous, metamorphic, and sedimentary rocks. It is highly resistant to both mechanical and chemical weathering. This durability makes it a dominant mineral of the mountaintops, and it's a primary constituent of the beach, river, and desert sands. Quartz has a trigonal crystal system. Its chemical classification is a silicate. In color, you have the macrocrystalline quartz like amethyst, citrine, pink quartz, rose quartz, and then on the other side you have the crypto or microcrystalline quartz like agate, carnelian, onyx, and then some grainy varieties like jasper, chert, flint, and plasma. In primitive uses, because of quartz conchoidal fractures, it has been used for thousands of years to knap stone points and other primitive tools. Modern uses, because of high purity silica sands, it's used in glass making, fiberglass. It's used as an abrasive for sandblasting and grinding because of its hardness and durability, and it's also used in the petroleum industry. Hey guys, we brought our mineral specimens out of the wash and back to my backyard to perform a couple simple tests to make sure we really are dealing with quartz and not a similar mineral like calcite or maybe even dolomite. So a simple test you can do at home, just buying some simple vinegar, which will have at least 5% acetic acid, is we can pour some vinegar onto the rock or mineral and see if we get a fizz. And that fizz, if it's calcite, would be the carbon being released from the calcite. Calcite is one of the Earth's largest carbon repositories, meaning it's holding a lot of carbon inside of it. And the reaction between the acetic acid and the calcite releases those carbon bubbles. So if it's calcite, we will see a reaction. Alright, so I'm going to take a piece of calcite I actually broke down because we don't want to use a weathered piece. So it's freshly broken. I'm going to put it into my glass jar, and I'm going to put some acetic acid into the jar. And what I'm looking for here is any sort of carbon bubbles being released, which I do not see. Another thing we can do here is I could pour just a little bit onto my specimen here, and I know this isn't your most professional acid test, but this is a test you could do at home very simply. Sometimes you will need a hand lens to notice any of this fizz or reaction happening, but it's clearly not happening with this specimen, meaning it might be quartz. But there's one other test that we can do to make sure that this is in fact quartz. So we tested to see if it was calcite. We noticed no reaction whatsoever. Another thing we can do is to check if it's dolomite would be to break it down into a powder like I've done here with just my rock hammer. I'm going to put this into my glass, just the powdered specimen now. And again, just pour a little bit of the acetic acid inside, and I'm looking for any sort of reaction. Nothing, okay? Nothing. So it's not dolomite, most likely it's not calcite. Let's do a hardness test. Now we know that quartz is at a hardness of 7, and it should be able to scratch glass. So I'm going to take this specimen that we were just pouring the acetic acid on, and I'm going to see if I could scratch the glass. And it clearly scratched the glass right here, meaning I cannot wipe or polish that scratch away. It is on there permanently. So it is definitely quartz.